Hey gang, today we're going to continue finding the equation of an exponential graph. Yesterday we did that by looking at a table of values that would match an exponential graph. Today we're going to do that just by being given 2 points from an exponential graph. So the process to do this looks a little intimidating, but I promise once we start doing them, you're going to be able to do it without a problem. So to determine the equation of an exponential graph, y equals ab to the x, see the model below. So in the model, I gave you 2 points. From the 2 points, I created a ratio right here and used that ratio to solve for b. So I have 16 equals ab to the third. How did I do that? Well, I did that because in this coordinate, the 3 is the x and the 16 is the y. And I matched them up to the equation here. And then I put it over the second coordinate where 2 is the x and 4 is the y. Rewrote the equation. That allowed me to solve for b because the a's cancel out. And then b to the third over b to the second is just b because remember we subtract the exponents. And then 16 divided by 4 is 4. So then once I had b, I put that into the equation with one set of coordinates. So 4 equals a times 4 squared because I have the coordinate 2 and 4 and use that to solve for a. So 4 squared is 16. That leaves me with 16a. Divide both sides by 16 and 4/16 is 1/4. Now I have a is 1/4 and b is 4. Put that into y equals ab to the x, and we come up with this equation here, 1/4 times 4 to the x. Okay, so we're going to use that process a couple times today, and then you'll be on your own trying some at the end of the lesson. So here's our first example. So again, we have to start by recalling this equation and using that to create a ratio. Now, I like to put the higher numbers in the numerator. I think it makes it a little bit easier. So I'm going to start with 54 equals ab to the fourth over 6 equals ab squared. Now I can cancel out my a's and I get 54 divided by 6, which is 9, equals b squared. Now I have to get rid of that squared, so I do the square root, and the square root of 9 is 3 because 3 times 3 makes 9. So now I have my b value, and I can plug that into our equation. So now we have y equals a times 3 to the x, and I can plug in one of the coordinates. So I'm going to plug in 6 equals a times 3 squared. So 6 equals 9a because 3 squared is 9. Dividing by 9, I get a equals 6/9 or 2/3. So now I have my a and my b, and my final answer is y equals 2/3 times 3 to the x. All right, so hopefully you see how I'm doing that. We're going to try 3 more examples. So let's try it again. Okay, here we have 2 and 128 and -1 and 16. I'm going to put the 2 and 128 in the numerator. So 128 equals ab squared over 16 equals ab to the negative first. The a's cancel out. 128 divided by 16 is 8. And we are left with b to some power. Now, this is where it gets a little tricky because we're subtracting here, but we're subtracting a negative. Remember, when you subtract a negative, it makes it like addition. So this is 2 minus -1, which becomes 3. So it's b to the third. And now I take the cubed root of 8. And if you don't know that off the top of your head, it's what number you multiply by itself 3 times to get 8. You can use your calculator. You're going to press math and go down to the cube root option, press enter, and then put 8 inside. Now, some calculators work a little differently, so if yours is not like this, raise your hand and I will help you out at this point. Press equals, and we get 2. And that makes sense because 2 times 2 is 4, times 2 again is 8. So b equals 2. Now we plug that back in. So I can do 128 equals a times 2 squared if I'm leaving this coordinate in. So that's 128 equals a times 4. Divide by 4, and we have our a value. 4 goes into 12 3 times, and 8 twice, so it's 32. And then we can rewrite our equation. Y equals 32 times 2 to the x. All right, let's take a look at the third example. So in number 3, again, we have negative exponents, which makes it tricky, so be very careful here and pay close attention. We have 125 equals ab to the negative third over 25 equals ab to the negative second. The a's cancel out. 125 divided by 25 is 5. And then negative 3 minus negative 2 is negative 3 plus 2, which is negative 1. So it's b to the negative first. We do the negative first square root of 5, which we can do the same way in our calculator. So we press math. We choose the option that has the x for the root symbol. We're going to put negative 1 there and then 5 inside, which gives us 0.2, which we could turn into a fraction by pressing math and then number 1 for fraction is 1/5. And if you remember earlier or last week when we did those negative exponent rules, that would make sense. So our b value is 1/5. We can plug that back in. So I'm going to do 25 equals a times 1/5 to the negative second. So 25 equals a, and then we can do 1/5 to the negative second, and that's 25, which again, based on those rules we learned last week, should make sense. Divide by 25, and a equals 1. Now, if a equals 1, we really don't have to put it in our equation, so it's just y equals 1 times 1/5 to the x, or just 1/5 to the x. Okay, so there's a lot of fancy things going on there with the calculator. If your calculator is not cooperating, let me know and I'll show you how to use yours. Let's try one more example. Number 4. All right, this time no negatives makes it a lot easier. I'm going to put 764 in the numerator, so 64 equals ab to the 7th over 16 equals ab to the 5th. A's cancel out. 64 divided by 16 is 4 equals 7 minus 5, which is 2, so b squared. Take the square root, really easy because the square root of 4 is just 2. Now we plug that back in, so we have 16 equals a times 2 to the 5th. So 16 equals a times, I believe it's 32. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 one last time is 32. Divide by 32, and a equals, well, 16 is half of 32, so it's just 1/2. Rewrite our equation, y equals ab to the x, so 1/2 times 2 to the x. Okay, so hopefully you're seeing how I'm getting those problems set up and you're ready to try it on your own. So you're going to try 5 through 10. Make sure you're checking in with me so I can be sure that you're getting it right before moving on to today's exit tickets.